Good morning, everybody. It's good to have you on the webinar this morning. I hope you all get a lot from it. My name is Jonathan Brindley, and I'm pleased from JBUS, and I'm pleased to say that I'm joined today by Jan Coquillet from SENSYS. Jan is an applications engineer, and he's here to give us an overview on certain aspects of the solution, and also he'll be involved in Q&A at the end. So if you've got any questions, get them in, and you'll see them as we answer them. You'll see them appear in the system. So then let's get started, get kicked off, and go to the contents of what we're going to talk about today. So I'm just going to a little bit about JBUS for those people that aren't really aware of what we do. I'm then going to touch on the solution components, or what I call the core components of the system. Have a look a little bit about on Skyhub 3 and TubeTrain following. Then move on to the SENSYS R4 Magnetometer and look at that in more detail and how it all connects up. Look at some applications. It'll be a brief overview, but all the same, look through those and we'll give people some ideas. And I'm going to touch on some data. No trade secrets, I'm afraid, but at least it will give you a good view of what to expect, and certainly what SENSYS have seen. And then Jan is here today to give us an overview of Data Tool, and there's been some updates on Data Tool, so that's very, I'm quite interested in hearing about that. And also hopefully we'll have time to touch on Magneto as well, which is the sort of premium processing tool from SENSYS. And then at the end we'll have Q&A. So yeah, like I said, if you've got questions, please fire them in. There's what they say, there's no really bad questions. It's so yeah, just get them in. We'll see what we can do. So just a little bit about JBUS to start with. We are the official UK UAV solutions partner for SENSYS in the UK. We're working very closely with them on always dealing with on a weekly basis on various projects. And yeah, it's a very good working relationship, working very closely. Been partners for quite a while now, yeah, you were able to get a good service from SENSYS, and it's something to bear in mind when you're looking around for this kind of technology, that if you come to ourselves in the UK, then we'd be looking to get things done quickly and provide a really good service with SENSYS backup. So a little bit more about what we or some of the other things we get involved in. So we are really, like I said, strong partners with SENSYS on the magnetometry, but we also do thermal systems, works well cameras, for instance. So we're involved in that for both agriculture and inspections for oil and gas and power, and the list, as you'll be aware, the list goes on and on. Also involved in methane laser systems using the Pergam Falcon. For those who've followed us for a while will know we've done a lot of work with various universities in this regard, trying to push forward the flux quantification methodology. We are also involved in mold detection, sonar systems, echo sonar systems, which seems to be showing some really good interest for the market at the moment. And then lastly, those again that have followed us will know we do have GPR systems now that we can trial. So yeah, we can cover all those posts for you. Get in touch if there's anything that you think we could help you with, or you're just interested, then please, yeah, just get in touch with us afterwards. So let's look at the solution then that we're here to talk about today, the R4, and look at the solution components. So the core solution components, as far as we need to know, are first of all the SENSYS R4 magnetometer, so the magnetometer itself, and you can see that in the picture. It's the long rod at the bottom of the drone. We've then got the R4 data recorder, which you can see nicely as number 2 there, sitting in proud in front of the M300. We've then got UGCS SkyHub 3, which is the latest revision, latest release from SPH Engineering for the onboard computer system, and that you can see that positioned on the left-hand side of the drone. And integrated into that is a radar system and radar true terrain following feature called TTF, and that is positioned. You need to be keen-eyed to see it, but it's just below the recorder, and we'll touch on that a little bit more. Now, on top of that, obviously, some other bits and bobs, in which we'll cover. And I've got a little picture here to sort of like quickly review those. So we've got the power and data cables, fastening cradle, and also some USB with all useful bits of software on. Data tool being one of them, and that'll be covered by Jan a bit later on. So let's have a look at the SkyHub integration. So SkyHub's integration. What is SkyHub's role in all of this? Well, it's syncing with the M300. It's able to take the GPS data from the M300 and it's then able to use that. So that's a big role of it that it has, is taking the RTK from the drone. It's also syncing the ground control software, UGCS Pro in this case, with the true terrain following via another bit of software called Custom Payload Monitor. It's also managing the obstacle detection radar if you've got one fitted. If you've got any questions on that, please send them in. And it's also, as we touched on just in the last slide with the power cable, it's also, SkyHub is also providing power for the R4. The R4 doesn't have its own power supply on board, unlike the R3. So we're needing to provide power into the R4 from SkyHub. So SkyHub is taking the power from the M300. It's then sending that power out at a given voltage. In this case, 12 to 18 volts for the R4. And then lastly, I touched on it just a minute ago. We're sending the GPS data to the R4 recorder. For those that know the SkyHub system, you'll see straight away that we're not fusing data with telemetry in SkyHub for downloading to various file types. We don't do that with the R4 because the R4 has its own recording system, or SENSYS in general. They have their own recording systems. We don't take data into SkyHub to fuse for these file types. We simply just send out the GPS data to the recorder, and then you're downloading the data from the recorder directly. And we'll touch on that a bit later on, because there's been some developments in that regard as well. So that'll be quite interesting to touch on that. So I talked about before about CPM, or Custom Payload Monitor. I've heard people call it Custom Payload Manager, but yeah, whether it's monitor or manager, CPM's role is really to manage the payload. In the case of the R4, it's managing the true terrain following. So what we're doing there is we are just setting a target altitude and a safe altitude. Now, this particular picture has speed in meters per second. Now, SkyHub, this is an old picture, it's been updated now. We don't do that within the CPM. The speed is actually controlled through UGCS Pro, which gives us a lot more flexibility. And that is something that you're going to learn as you go through the training. So the key aspects of CPM are that it's where we can control the drone low, let's say 1 meter above ground, in a safe manner. So we're putting into the TTF box there. You'll see it's highlighted yellow. We're putting in its target altitude, and then we're putting the speed within the UGCS Pro itself. You can see, needless to say, we're also planning the flight plan, or the mission plan in UGCS Pro as well. So essentially, these two bits of software are working together seamlessly. It's a very simple system, and yeah, it's literally I would say within 5 or 10 minutes you pretty much mastered how this system works. So very easy to get your head around. So let's look at the flux gate sensors. Why use flux gates in the first place? Just for those, a bit of this is a bit geeky, but yeah, if you've got any geeky questions, I'm sure Jan can answer them at the end. But why we're using the fluxgate sensors is that, I mean, first of all, it is a cost-effective solution to manufacture and use these sensors. So that's the first really plus point. The second is it's quite high sampling rate. So, you know, a standard version of the R4 is 200 hertz. So, you know, as a standard, it's got good resolution. Interesting to know that you can actually get higher hertz rates than that. There is a trade-off with processing time. So, for example, you could have the options you could have. If I remember rightly, and Jan, you maybe put me right at the end. You can have 200 options of 200, 250, 500, and 1,000, I believe. You'd need a very fast computer and quite a bit of time to process 1,000 hertz. So, like I said, it's a bit of a trade-off. You've got to choose the right horse for the course. So, in 9 times out of 10, 200 hertz is good enough. But there might be applications where you know the deeper we delve into that application, we find that actually you might be better off looking at something else. But like I said, 9 times out of 10, 200 hertz is okay. With this high sampling rate, what that means is that we can get rid of a lot of noise that we don't want out of the system. I mean, some examples. The examples here, like power lines, you know, the 50, 60 hertz issue. You know, we can clearly see that in the data, and that can be stripped out. Fluxgates also allow separate measurements of X, Y, and Z for enhanced interpretation. It's not something that really, I guess, we see we would see using the system. But whenever I've spoken to the applications engineers at SENSYS, it's more in the background of the data tool and how it actually uses that data then to streamline the process flow and make it really easy to get the data out and the results you need. So it's very clever in that regard. But fluxgates allow you to do that, or allow SENSYS to do that, and that's one of the reasons why it's used. Another good reason, yeah, well, they're really light. When you've actually had an R4 in your hand with without the recorder's got a bit of weight to it, but the pole itself is, well, there's hardly any weight to it at all. So the fluxgates are really light. Just means that the whole overall package, even with the recorder, is really easy to to move around. It's not cumbersome at all. So that obviously when you're in the field, and that's the last thing you want. So anything that helps you there is a good thing. Again, this is more of a geeky thing, but I mean, there's no dead zones. The fluxgates are omnidirectional, so it doesn't matter where you are around the globe or in the world, for example. It has that flexibility, and again, that there is the reasons that we could go into this in far more detail, and that obviously Jan's here today. And if there are any questions in this regard about this particular aspect, then please, fire away, and we can answer those. The last one at the end, I think I've kind of covered it. The whole setup, the whole ethos behind the processing software that you get from SENSYS is that it's really easy. I mean, the whole ethos is to make it as easy as possible for the user to get the data that they need to, provide their customer or the project with the outcomes that they need. And the process flow is very, very simple. Unbelievably simple, actually. And as I said, Jan will touch on that a bit later when he goes through the data tool and how that works through into their own premium processing software called Magneto. So yeah, it's a really simple it's a simple method of getting the data you want, which is great. It suits me for sure. So a bit of an overview, some key features then. First of all, yeah, the R4, that pole that you saw, the 2 meters in length, it has these fluxgate sensors at 50 centimeter spacing. That's the first thing. So you've got 5 on a pole. And those that know the R3 has 2 a meter. So yeah, better resolution, and also you've got a wider swath than the R3. It's still only coming in at 1.6 kilograms. So in my experience, if you've got on a very, very calm day with no wind, you can easily hit 25 minutes, even maybe a little bit more. So in ideal conditions, you're looking at 25 minutes flight time. I would say in the UK with light winds, which is quite common when you're out in the fields, certainly when you're doing archaeology work, you're looking more at 20 minutes, just around 20 minutes, maybe a little bit more, but don't expect too much more. But still, you can still get a lot of work done in that time. So as a tool in the toolbox, it's all thumbs up. And I suppose, the next thing I said here, the coverage of what it can do depends on the size of what you're actually looking for. Archaeology, you're going to be fine, well, slower than you would for example, unexploded ordnance investigation, where you could fly it sort of two meters per second and above. But for archaeology, you tend to be flying it as those are in archaeology, you tend to be flying it at walking pace, which tends to be around 1 to 1.5 meters a second. So again, it will vary on application. So it's not as easy as me saying, oh, it's going to do this, because it all depends on your application. What I can say is, in some of the work that we've done, we've certainly some of the applications that we've done, we've shown that it's more than 2 times as fast as walking. And of course, you obviously don't get people get tired, and that can affect. But whereas with the drone, we don't get that. So, moving on, internal recorder. You're never going to run out of data. In terms of this could run, it's will run much more for longer than you'll be able to stay awake probably. So 120 hours of data is standard. I mean, there's plenty of space there for you to do your to actually keep your data on for a length of time. If you've got your own system, and then you can always revert it. You can always revert back to it as and when you need to. Data tool, I don't want to steal the thunder of Jan here, but there's lots of tools in data tool. One of which is you can go in and change. You can reduce the noise of motors and so on. I'll let Jan's. I hope Jan's going to go through that. So I'll leave that for Jan. This is really geeky, but for those, and I'm glad I've got Jan here with me today. But the last one there, resolution more than 150 picoteslas, or the steps between 150 picotesla between steps at 75,000 teslas at standard measurement range. Now, Jan can go into this in far more detail than I possibly could. So if you've got any questions, if you are of that at that level, and you really want to understand the technical aspects of that, please send the question in. That's why we got Jan here today, to go into more of that detail. Just in the top right corner here, you can see that I've also included a diagram just to underline the swath of the R4. Excuse me. So you can see there that we're looking at a swath of 2.5 meters between each line of the R4. You can do a lot of space using that swath. From practical experience, it's quite remarkable how quickly you can get through a field when you get your head down. So it's got a good swath to it, far more than the R3, and better resolution. So a bit about the assembly. On average, it takes me to set up, even with cable management, less than 10 minutes. So fast deployment in the field. It's probably going to take you longer to get to where you need to be than you are to set up in most cases, because it takes no time at all. It's a very simple setup. I tend to, with the R4, I tend to set up the attachment plate, as you can see on the screen there, the middle picture on the right, with the screws on and the black block. I tend to fit that before I go out, so it's already on the drone. and I'm simply just getting the R4 out and clicking it into place. And you can see the runners that will run along the edges of that plate, attachment plate. It simply clicks into place. It's very quick. So yeah, easily a lot less than 10 minutes, because everything just plugs into, it clicks into place. And you can see that also from the top picture there, the way that we fit the R4 to the legs of the drone. We are clicking it in place, so over the legs. So yeah, very easy to do, very quick, fast deployment. So connections of the R4. So we are, so in the top sort of top left-hand corner, you can see we have where we position the true terrain following. So on the R4, the ideal position for the true terrain following radar is directly below the recorder itself. We use, I mean, that's not sparing. I mean, I use a lot more Velcro than that. But once that you've got a good lot of surface area there, once you've pushed on the TTF, sorry, it really is not coming off. You really have to, pry it away. So it's very secure in that position, and we found that it gives very, very good TTF performance in that position, and like I said, that is the ideal position to have it. You can see one in the picture. One, that's the our Wi-Fi connection. Let's go straight to the top right corner. For 2024, we also have a LAN connection. So why use the Wi-Fi connect? What is that for? The Wi-Fi connection and the LAN connection. They're both ways of getting data out of the recorder. And we do that via a sort of like a portal-based system. So we're able to go directly into the recorder via a portal on your web browser, and we put our details in, and we can get into the data and then download the data. So as we're saying here on the slide, new for 2024 is a LAN connection. It makes things just a lot more cleaner. So you've got two options really. You can use the Wi-Fi to just in the normal way as you would do to any system. You log in via the Wi-Fi, and then you go into the portal, or alternatively you just do it via the LAN. So as solid connection. So that's good. It's a good to have that option. So that's a good development. So 3. You can see there that we've got our GPS connection in on 3. So that's coming directly from SkyHub. As we said earlier, we are taking the RTK data from the drone. We're then taking that from the SkyHub, and we're feeding that into the recorder into 3. 2, you can see there is a power cable. And that is the power coming directly out of SkyHub into the R4. And I think I mentioned before, we operate between 12 and 18 volts for the system. I mean, I operate at 12 volts, I believe. So, but yeah, and that is adjustable on SkyHub. So if you were to buy a SkyHub, you can easily just adjust the output of the power output. So really easy to do. One last thing that is probably worth of note is that the RTK in on 3 as you can see in the pictures in the bottom left and top right, that has been the cable has been redesigned. This is an old picture, and I apologize for that. I need to get this updated. But we now use a very similar L connector as you can see for 2. So next door to the 3 in the top right corner, we have 3, which is straight in, and 2, which is more of an L-shaped connection. We also have that on 4. 3 as well now for the RTK in. Again, it's just another safety feature, and yeah, it's a really good and welcomed improvement. So I spoke earlier about how we get the data from the R4, and that we've got 2 routes in now. We've got the Wi-Fi route, which is always which was originally how it was designed, but then now we've got this LAN connection in which we can go in. So you've got the two ways. But whichever one you do, once you get into the system, it's, as I was saying, it's a portal-based system. Once you put your credentials in, you can get into this portal, which you can see on the left-hand side, top left. And in this area, you're able to look at all the data that you've collected. There's some other things you can do, but just that's for another day. But you essentially can go in and look at all kinds of different features within here. But one of them is actually downloading the data. So once you've clicked into the data tab, you can then you'll see on the top on the right hand side, we then can download the data. You'll see it online in a simple file structure. You just click on that file that you want to download, or multiple files, one after the other. I tend to find, practically speaking, I don't like to click more than 5 at a time, because certainly with older laptops, what you find is that you accidentally skip on it. The computer doesn't read that you want to download a particular file. You've done 3 or 4 before, and then it does the next 2, and so 5 at a time is just a common sense. I think it's a common sense thing. Otherwise, you can find out that you're not sure what you've downloaded and what you did download. So yeah, 5 at a time is, and then once you know you've downloaded them, go to the next 5 and so on. So these files are then downloaded relatively quickly, I must say. It's it happens really quickly. Even files sort of 50 megabytes at a time, still download quite quickly. They're downloaded in a standard format called PMLXF. This is the standard format that comes out of the R4 and then can be downloaded into the SENSYS data tool. As I said before, I don't want to steal Jan's thunder, because Jan's going to talk about that in a bit more detail. So, but that's the process for the download flow, how we get the data off the R4 into the SENSYS data tool. Yeah, how do we operate the R4 once it's sat there on the drone? Before it takes off, we simply press the red button. As you can see, it's on the bottom left-hand corner. It's on the side of the R4. Just for information, there is a way of doing that automatically from the portal, but I don't tend to do that. But I tend to do it. I find it much easier to start the R4 just physically by pushing the red button, listening to the beeps every second, beep, 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 just like that. And then when the drone lands, you just press it again, and the beeping stops. And then that's when you know that the recorder has recorded that flight into the recorder, and that is a line item, as you see in the top right corner. That'll be one of those line items. So that's how easy it is. Honestly, the amount of effort that SENSYS have put into getting this system to a place where just with a little bit of training, you can download the data and process it. I mean, it's really useful, and it's it's a pat on the back, I think. So applications overview. Yeah, before we get into that, I'll let you read the top bit. But essentially, if you're looking for smaller ferrous targets, then you need to. The general rule is be safe, but try and fly as close to the ground as you feel comfortable, and also fly, but please fly to the conditions. So people with experience with and in certain conditions, then you could probably reduce it to sort of a meter, or maybe even more, even less. But yeah, just be safe and be practical, and then things will be all right. So here's the sort of overview of applications that I mean I've got involved in so far, and I'm obviously aware of them through talking to SENSYS as well. Scouting UXO, extensive. I mean, the system was designed for this application, and it does that really well. So and as for those that are in UX, you work with UXO companies, a lot of you will be using the R3 or not the R4 already. So you'll know that it's an effective piece of kit for that. Also used in mining applications, so looking for ferrous indications. There's a picture there on the bottom right-hand corner of an example of that. Detecting buried tanks, concrete, and metal. So if it's rebarred, for instance, there's a big ferrous content there. So that the R4 is really good for that. In fact, I've done a couple of applications for finding pylon bases, and we found those. So that's, yeah, it's rebar is very good. Mapping ferrous utility pipes. Yeah, I've done quite a few applications now doing utility pipes, trying to locate them and confirm that the CAD drawings were correct, and that's been quite useful. Also good, actually, top right-hand corner, power cables. You know, high voltage, in this case, I think it was 132 kVA, but again, overlaid onto CAD and confirm, or you know, can confirm whether those CAD drawings are still correct, whether these lines have not been, you know, dug up like 15 years ago, but everybody's lost the data for it. Also, mapping archaeology, another application that I've been heavily involved in. Yeah, so you know, as a scouting tool. I mean, 9 times out of 10, the archaeology fraternity are going to be using CART. Of course they are. But more and more, especially where my family are from, in the Fens, we get a lot of waterlogged fields. And if you just happen to have a project which, you know, lands at the wrong time, and you've got half the field at which you want to look at, which is under, like, you know, 30 centimeters of water, it's going to be very difficult to put a cart through that. So it's a tool in the toolbox that can allow you to go and find something that probably you might not have been able to find. You know, I know another example is crops, for instance, where you've got crops growing. You can't put a cart through that. The farmer isn't really that happy about that, but maybe you can go over the top of it. So like I said, it's a tool in the toolbox for archaeology. You know, so it holds its own. And then you have, of course, artifacts, ions, tools, you know, anything that's ferrous. So it will be able to find these things, depending on its size, of course. And then, yeah, infrastructure as well. As I mean, it's kind of part of archaeology, but yeah. So it is a quite versatile piece of kit. You know, quite a lot of applications it can be used for. Again, if you want to know more, please ask questions. Please send the questions in. Me and Yana will answer them. We're going to try and leave as much time as we can at the end to answer these questions for you. So, yeah, don't be shy. Get them in. Just some observations. So we've found for archaeology work, we've been flying the R4 best at 1.5, well, 1.5 meters a second, and then, as you know, as low as you, again, it's the same as I said before. Practically and safely, you can fly it as low as you possibly can. But 1.5 meters walking pace, it seems to deliver good results. So that's, you know, as a scouting tool, where you haven't got another tool in the toolbox, it does a job. So that's something to just bear in mind. You know, it's not just like we're going to talk about UXO. It's not just the UXO tool. It's got other applications as well. UXO, 50 kilogram target, and this is through testing that we've done. 50 kilogram targets at 1 or less AGL to 4 meter depth, and the R4 around 1.5 kilogram targets at 1 meter AGL to around 0.5 meter depth. Yeah, questions on that, please ask away in the Q&A, or come and see me afterwards, or, you know, give me a call. I'm quite happy to talk about that. So let's have a look at a little bit more into the data. I've got a few more minutes left, so let's just look at the data. This is SENSYS' own test area, and they use their Magneto VX-V3 here, which is their large area magnetometer ground system with 16 flux gate gradiometers. 56 targets. You can see them all there. Some small ones, some large ones. So basically, what this data, again, this is something that we can share with you. But you know, I can just give you a kind of an overview synopsis of it really quickly. There are some spurious data. There is spurious data in there, but and the length and target of the orientation will have a bearing on the results. Of course they will. But of the 56 targets identified by the MX3, the R4 missed 12 of those, and they were around 0.6 meters AGL, so quite, still fairly quite low under the ground, high depth under the ground. And the majority of these were 2 kilograms at more than 0.3 meter depth. So there seems to be an area there. As I said, my experience suggests that the R4 is capable of picking up, let's say, 500 grams in the near surface to around 0.3 meters. So, yeah, if you want to know more about what we found here, then get in touch. So, but the overview here is that the R4 holds its own. It's an airborne system, and majority of these targets have been located, and they're, yeah, it's done really well. If you want to know more, then please get in touch, and we can, and either myself or SENSYS can go into it in a little bit more detail. So just a little bit of what we are providing here at JBUS. So that's really, well, let's just go back. That's the main presentation. What I wanted to talk about. I'm going to hand you over to Jan in a minute, but just a little bit about what JBUS can offer you in terms of getting you set up with the R4. So yeah, we're happy to market the R4, but we can also do hires as well. We are able to hire you SkyHub TTF, come and configure it, set it all up for you. We can do sort of familiarity days, training days, offer demonstrations, trial days, and then obviously if there is a requirement for support of project, then we would look at that on a project by project basis, but try to stay away from project work if we can. But yeah, so yeah, there's a lot of opportunity there to get you into using the R4 and understanding it. And if we can help you, please, come and have a chat with me, and we'll see what we can do. Anyway, that's my part of the presentation over, and thank you very much for listening. I hope it's giving you just enough flavour for you to say, we want to know a little bit more about this now. So yeah, I will hand you over to Jan now. So Jan, the floor is yours.
So thank you, Jonathan, for the introduction of the R4, and hello also from my side, and greetings from Germany. I hope you can hear me, and so let's get started. I just try to share my screen with you, and I hope you can see it now. Okay, before I will start with a live data processing section with the R4. I want to start with a first overview, a general overview of the MacDrone data tool. So the MacDrone data tool is a tool for pre-processing of the raw data of all our MacDrone devices, MacDrone R4, but also MacDrone R3, as well as MacWalk and MacBase. All this data can be imported in the MacDrone data tool, and then you have 3 possibilities of export. The first one is CSV export, and it's really just to make the raw data readable. So you have binary raw data from the systems, and you have the possibility to translate it into ASCII-based data and do all the processing for yourself. The second export possibility is the UXO file. That's also ASCII-based, but this export uses all the features of the MacDrone data tool, and it is created for, as interface for Magneto, our post-processing software. So that's a special format for importing in Magneto. And the third thing is a normal ASCII export for customer-specific processing. So if you, for example, use Oasis Montage or other software, then you can use this export. Yes, and now to the key features of the Magnetron data tool. I will show it in detail after that with the live data processing, but here a short overview. So it does track detection. And as Jonathan already mentioned, there's a lot of noise from net frequencies or the drone itself. So there's a possibility to filter that out. And of course, you can do a compensation. That means what we measure is the total field, but what we want to see at the end is the anomaly of it. So we have to compensate the data. You can do a lot of offset corrections, remove track overlapping, and you also, but that's more for the Magnetron R3, you can integrate MacBase data. That is a magnetic base station, but that's not needed for UXO detection. Also, you can integrate external GNSS data, but in this case with the R4, it's also not needed. You can import calibration data. I will show that. And as I mentioned before, you have various exports. You can downsample the data, and at the end of the processing, you will get a preview, a first preview of the resulting color-coded map. And of course, there are a lot features in the background of the tool that the user doesn't recognize. For example, whether you fly with a U-turn or you use heading hold. So in this case, the blue line is the first sensor and the red line is the second sensor. And in this case, with heading hold, in the first track, the first sensor is on the left side, and in the second track, it's on the right side. But you can switch it as you want, because the data tool automatically recognizes what you have done, and that's possible because of the single axis X, Y, and Z of the magnetometers. So all this is done in the background. Okay. Let's start with the Magnetron data tool. I'd like to start with two basic new features. I think most of you have already seen the Magnetron data tool, so let's start with some new features. The first one is that you can now import more than one file. I don't know what data it is, so I think it takes some seconds. Okay, and that's why you have a new tab here. It's called Files. And when you click on one measurement, then it is highlighted here in blue. And of course, you can now add additional measurements or remove selection or remove all. So that's the first new feature to use more than one measurement. And another one is, as I mentioned before, there's a possibility to include a calibration record. And the new thing about that is that you can have a look at the data before. So I hope you see this additional screen here. So you see the record you've done, and the result is even more better when you select a special section of it. So let's say the first section is the start of the drone and the flight to the location where you do the calibration flight, and here at the end you have the landing procedure, and you just want to use this data here in this section as calibration record. So that's the second new thing. And now I remove all this again, and I want to go through the tool with you with a sample file from our test range. So what you see at first in the tool in this visualization window, it's just the GPS track. So that's no magnetic data, that's just yeah, the track you recorded. And the first thing what we have to do is so-called track detection, because we just want to use the data within the tracks and not the start and the landing and not the turning maneuvers, because yeah, that's not usable as data. So that's why we have the track detection here. In most cases, you just have to click detect because the default settings are okay. So you click detect, and then you have 7 tracks here. So the red data will be deleted and not used for processing, and the blue data is what remains for processing. And now you see here there is a 7th track that is from the landing, I think, and this is not useful data. So I have 2 possibilities. The first one is heading-based removal. That means that all tracks that don't have the same heading as the most tracks will also be deleted. So now you just have the 6 tracks. But in this case, you could also increase the minimum track length to, let's say, 30 meter, and then you also don't have this track here at the side. Okay, so first step is always track detection. Otherwise, you just could do the CSV export with the raw data. Here in the export options, you have the possibilities I mentioned before, the UXO format, the ASCII formats, and the raw data output. But today I want to show the UXO export because we want to have a quick look into Magneto. Okay. Next step is filtering. Also here with R4 and UXO detection, I think in most cases the default settings are very useful and you don't have to change anything. So what we have here is a smoothing filter to reduce but to eliminate the noise from the drone and other noise, and the compensation. So moving median with 15 meter track length is, yeah, it's a good default value. So I won't change anything here. Offsets, important here is the GNSS time offset, because we are getting coordinates out of the drone, and sometimes there is a time delay. In this case, I know it is 250 milliseconds. It should come out of the SkyHub, so but you can correct it here. MacBase import is not needed here, and the last sub would be GNSS import, but as I mentioned before, you don't need to do it here in this case. So, and last point is downsampling, because we have 200 Hertz. So even if we fly with 3 meters per second, then we have a data point every 1.5 centimeters. That's really enough. So I will use this downsampling here to speed up the processing. So and then I just have to click export, and everything is done. And we will see the preview at the moment. The longest part is to write the UXO file in this case. So, and here you get the preview of the result. Yeah, it's like the data you saw before with Jonathan. It's our test range. Okay, so and that's it for the moment for the data tool. Let's go to Magneto now. Key features of Magneto. So you have a really fast map creation. So you get a display of the measurement values as color-coded map, also borehole, but that's something else. And object calculation. So I will show it. I will show it with the data. Yes, you can integrate a lot of things, and yeah, of course you can create and export object lists and object maps. Yes, so I don't want to go in detail here. I just want to show you what we can do with the R4 data here. So I created the UXO file in the Magnetometer data tool, and now I want to import this, I think, from the desktop. So I have to choose a UXO 64 format. Here is the UXO file. Okay, and here you see the resulting map. In Magneto, it's not so nice like in the preview of the tool, but that's okay. To calculate the objects, you just have to choose this blue flag and click on the map. Adjust the circle here to cover the whole signature of the object, like this, and press enter, and you get a result. So that is an object in 2 meter distance with a magnetic moment of 19 ampere square meters. And this you can do with all objects you want to pick. You get an object list here with all possible parameters. And these object lists, of course, can be exported as GPX or KML or shapefile or whatever you need. The last thing I want to show here in Magneto is to export a GeoTIFF and import it in a GIS system. So you click on the map, click on export, choose GeoTIFF, desktop test, okay. And you have to enter the correct EPSG code. Magneto has an integrated GeoServer, and you can use any coordinate system you need. You just have to enter the EPSG code. In this case, it is UTM zone 33. Okay, now with GIS. Test, drag and drop. Okay, here I also have to enter the EPSG code. And here you you find the map. This is our SENSYS premises. Here's our test range. Last step could be to add a transparency to the white color. Okay, and here you see, yeah, the map in the GIS system. Okay, I think my time is over, and I think it's your turn again, Jonathan.
Yeah. Thanks very much. Yeah, I have. Thanks very much for explaining the data tool and the new additions that we've got. The ability to merge files within data tool is really, really useful. I can definitely vouch for that. It cuts the process, even though it's a little bit of processing time anyway, but cuts it down even further, which is great. Yeah, the collaboration flight is really useful as well. So yeah, thanks very much for explaining that, Jan. That's really good.
Thank you.
Yeah, I've just been answering some of the questions that we've had. I'm conscious we've got 5 minutes, but I think I've done the majority of them already. But there is one from Michael Piz. I hope I've got that right. He says, as the intensity of magnetic field drops with the cube of distance, do you have any positive survey results on prehistoric archaeological sites where features recorded with pedestrian survey are usually within the magnitude range of plus or minus 5 nanotesla? What is the lowest realistic height AGL for a survey with a setup on an M300? Yeah, do you want to have a go?
Yeah, so the lowest realistic height, I think, so we did 0.5 meter. I wouldn't want to go lower, to be honest, but 0.5 meter is possible in ideal conditions. And yes, we should have results, but I didn't prepare it. So my colleague Markus had a project last year with archaeology and the R4. So Michael, I could send you an email after it. I have to search for it.
Okay. Let's say this then. I'll just type in. Well, that's okay. So just
okay.
Yeah, I think that's pretty much. We're 12 questions. I think just trying to see if there's anything that really you could answer a little bit better than I could, or add something to. Yeah, no, that's the only one that I saw that was really. Oh yeah, there was a question on data tool, but you covered it in your little part that you did. So that was really good. Okay, look, there is just one question that's just come in. I think I'll just see if I've actually answered it. 1 second. Yeah, no, I think we've answered everything. Yeah, that's good. All right, so
sorry, Jonathan. There's
yeah,
the last question from.
I'm just going to look.
Diglin.
Yeah, okay. So open 4 questions. We are asking. Okay, Mike. We are asking regards to would you class it as a reconnaissance tool? Would not be compatible to a cart hand, but gives good indication of heavily contaminated areas. Actually, I can say that the test that we've done in the UK is that at the 0.75 AGL level, it's comparable to handheld. So that was using small, I wouldn't say small arms, but certainly smaller ferrous targets to larger ferrous targets. And the results that we've seen, the feedback we've got from our UXO customers is that when it's flown at that lower level, I mean, we had Jan said 0.5, 0.75. Anyway, low. It is comparable. So I wouldn't say it's. I mean, I'm sorry that I used the word scouting. I meant it from an archaeology perspective, where you just want to see if that feature goes under a waterlogged area because you've got no other way of seeing it. But from a UXO perspective, this was designed for UXO, so it's a very, very good tool. And Jan, what would you say in terms of resolution? Much better resolution than the R3, right?
Yes, of course. R3 just has 1 meter distance between the sensors, and here you have 0.5 meter. So, of course, you can't find small mines, but most of UXO can be detected with the R4.
Yeah. Okay. So, yeah. Let's have a look. Hi, Jan. Still don't understand the calibration flights. Do you still? Hi, Jan. Still don't understand the calibration flights. Do you do a separate calibration flight?
Yeah. I'd like to share my screen again. So yes, that is separate recording for a calibration flight, and this is what you see now is part of the user manual of the R4, and here you see in detail what we recommend to do for a calibration flight. So it to make it easy, it is fly forward and backward in all directions: east, south, west, and north, and that is used as calibration flight.
Okay, good stuff. Yeah. Okay, Andrew Lay. Yeah. So yeah. Do you specify some minimum UXO standards as per IMAS, e.g., an F1 grenade to a depth of X meters, as in International Mine Action Standards? Simply stating very good is not helpful when trying to meet technical standards. Okay, it's true. So, but in regards to standards, do SENSYS provide a set of standards that the R4 for UXO meets?
I'm not sure, to be honest. The thing is that you can't give general information, because it if an object is detectable at a certain range, always depends on the object itself, on the magnetic properties, and also on the conditions. And that's why we usually don't say, for example, that you can always find a bomb in 4 meter distance.
Yeah.
That always depends.
Okay. That's actually very good. Oh, this is Richard Holmes. Sorry. Okay. Yeah. Okay. So hopefully that answers it. It's probably not the answer you wanted, Richard, but at least what it does do is I think it comes down to the proof is in the pudding. You know, when you get out there and actually do your own tests and actually see for yourself, you get the IP. So yeah. But as I've said already, it's my feedback that I've got is that it's on par with, and that was a UXO test that I'm talking about. So a UXO trial, and they were saying it was on par with their expectations with their handheld technology. So hopefully that helps to some extent. There are a couple of other ones, but no, I'll answer them after. But yeah, I mean, yeah, we're over time, but Jan, can I just say thanks very much for coming on the call? I really appreciate it. I can't believe the amount of questions we've had. It's been absolute, it just shows that there's a lot of interest in this technology and how far you've actually brought it. It's all down to the processing side and how streamlined this has been made for the user experience, which is really, really good. It's definitely leading the market, I think. So thank you very much, everybody, for coming on the call. I think this has been a really eye-opening webinar of the amount of interest we've had. Please don't be shy. Come and talk to us afterwards. if we can come and do a familiarity day, obviously we're backed by SENSYS. We can really help you on that customer journey to getting what you want, and whether it's gonna solve the issues that you would want the technology to solve. But thanks very much, everybody, yeah, have a great rest of the day.
Bye bye.
Bye.